Hey there, welcome to Pomodoro Joe for Friday, November 10th, 2023. Today we're looking at LeetCode problem 1743. Restore the array from adjacent pairs. This is a medium problem. So there is an integer array, nums, that consists of n unique elements, but you have forgotten it. Okay, so we have some array, nums, but we forget what it is, and we aren't given that nums, so that's a problem. However, you do remember every pair of adjacent elements in nums. So that means we don't necessarily remember the entire array as it is, but we can remember which numbers are next to each other. You are given a 2D integer array, adjacent pairs, of size n-1, where each adjacent pair's index I is equal to u sub I, v sub I. Indicates that the element u sub I and v sub I are adjacent in nums. Okay, so we're given a list of lists, and each element in our list is going to be a list of two elements, and we just know that these two elements were next to each other in the original nums array. It is guaranteed that every adjacent pair of elements, nums index I and nums index I plus 1, will exist in adjacent pairs. So every single pair of elements will be in our adjacent pairs, either as nums I plus 1, or nums I plus 1, nums I. The pairs can appear in any order. That's going to make it a little bit more challenging. Return the original array nums. If there are multiple solutions, return any of them. All right, so we started with some array of integers, and it looks like they are unique integers. So that's important to know. So we started with some array of unique integers, but we've forgotten what it is. However, we do remember which numbers are next to each other. So we're given this adjacent pairs. This is a list of all the numbers that are next to each other. So in our original array, 2 was next to 1. Now we don't know the order. It doesn't mean 2 came before 1 or 1 came before 2. We just know that these two were next to each other. So 2 was next to 1, 3 was next to 4, and 3 was also next to 2. Our goal is to reconstruct the original array. So I know that 2 and 3 were next to each other, and 3 and 4 were next to each other. So I know 3 is sandwiched somewhere between 2 and 4, all right? And I know 2 and 1 are next to each other. So 2 is sandwiched between 1 and 3. And let's see, this 1 doesn't have any other pairing. So that means that 1 is next to 2, but it's not next to any other numbers. So 1 must be an endpoint. And I think the same thing is true for 4. Since 4 is next to 3, but 4 is not next to any other number, 4 must also be an endpoint. So it must go 1, 2, 3, 4. And that's right. All right, we have another example here. 4, negative 2, 1, 4, negative 3, 1. So similarly, I can find the endpoints. So 4 has two pairs next to each other. So 4 is not an endpoint. Negative 2 doesn't have anything other than a 4 next to it, so negative 2 must be an endpoint. And negative 3, also nothing next to it, so negative 3 is an end, and 1 has two numbers, either 4 or negative 3. So we have our two endpoints, negative 2 and negative 3. So it could go 2, 4, 1, negative 3, or it could go 3, 1, 4, negative 2. All right. Cool. So I think we got this one. Let's put 25 minutes on the Pomodoro timer and we will get started. All right. So we can imagine this like a linked list. If you're familiar with linked lists, if you're not, you can think of this as a chain where every element is a link in the chain, and every element has one link to its left and another link to its right, except for the two end elements. The left end will only have a link to its right, and the right end will only have a link to its left. So what we want to do first is find our endpoints, because once we've found an endpoint, then all we have to do is follow the chain until we get to the other endpoint. So let's start here. We'll have some result. It'll be an empty list to start with, and we'll return our result at the end. Okay, so the first thing I think I want to do is go through our list of adjacent pairs and get this into a better format, something I can really work with. So let's build a dictionary where every key into our dictionary is one of our numbers, and every value is the list or set of its adjacent numbers. So we don't know the order, we just know that those two numbers will be either to the left or to the right, and we can build from that. All right, so let's start with this. We'll have an adjacent to dictionary. And this is going to be a default dictionary of either a list or a set. I'm going to choose a set just because it's a little bit easier to work with. Number one, it will guarantee uniqueness, so I don't have to worry about duplicates. It's also going to be a little bit, well, it probably will be a little bit more efficient. So let's use a set. Okay. Now, for every pair, we'll just do N1 and N2, N1 and N2. In adjacent pairs. Now again, we don't actually know the order. This is not going to give us the order. So that's another reason why using a set is kind of nice, because it will sort of erase any ordering thoughts that we have in our heads. So let's do this. We have an adjacent to. All right, we know that N1 is adjacent to N2, and we also know that N2 is adjacent to N1. We know these two numbers are next to each other. So adjacent to N1, we'll just add N2. And same thing in the other direction. Adjacent to for N2, we'll just add N1. All right, so we've built up our dictionary of our adjacent pairs. So the key will be the value of this node, and the value will be its adjacent nodes. That'll be the nodes to its left and right. So at this point, we can go through and find out, well, which one of our nodes only has one adjacent node? If it only has one adjacent node, then this node must be an endpoint, either the left or the right. So let's see, let's find the endpoint here. We can find both endpoints, but we don't really need to. We only need to find one. So let's just go through and find one endpoint. Okay, and for now, I'm going to set it to none because we don't know what it is. All right, for every key and value in our adjacent to, if our value only has one element, so if the length of our value is equal to 1, well, that means that this only has one connected link. So this one must be an endpoint. So we'll just set our endpoint to this key, and we'll break. We can stop our loop here. We found our endpoint. Now that we found our endpoint, we need to start building up our result by following the chain. So let's see here. We'll have our current value. That's just going to be the endpoint. All right, what else do we need? We need our previous value. And for this, because it's an endpoint, that's going to be none. And then we need to find our next value, but we can do that in a loop here. Okay, now we have our loop. So while we have some value that we need to add to our result, let's add this to our result. So result.append this value. All right, now we need to find the next value. So let's see, our next value is going to be none because we don't know what it is yet. So let's find our next value. Well, we can look up what are the nodes that are adjacent to this node. So let's see. Let's just go through for every node. Should I call this node? Sure. For every node in our adjacent to, for this node, this value. Okay, now this is where it's a little bit tricky. So we're going to look at the nodes that are adjacent to this node, and we have to pay attention that we don't backtrack. We don't go back to a previous node. So we can figure out which node is really the next one by checking these adjacent nodes and seeing if we already saw this one before. So if this node is the previous node, maybe I should call this next val in. No, I'll just call it node. So if this node is equal to our previous value, well, then we just came from this one. So that means we're not going to this one again. So that must mean it must be the other value in this adjacent to list or set. Let's do this. Let's say if the node is not equal to the previous value, then this node must be our next node. So our next value is equal to this node. And we can actually break at this point. All right, so now that we've found our next value, we can assign our previous value to this value. So pre-val becomes our current value because we're moving on. And then our current value becomes the next value. Cool. And then we just keep going until we run out of values. Now, one thing that I think I did wrong here, I don't know if you can spot this, but the one thing I think I did wrong is up here. While we have some value, let's take a look at our constraints. So our values can be anywhere from 10, let's see, negative 10 to the fifth to positive 10 to the fifth, which means that this value could be 0. And if we hit 0 in our while here, it's going to exit out. So I actually have to check if this value explicitly is not equal to none. Okay, let's give this a shot. Got an error, of course. So if you want to get the key and value out of a dictionary, you have to use the items method. So our dictionary.items as a function, that will return our key value pairs. All right, let's try that one more time. All right, seems to work. Let's see if this will pass all the tests. And we pass. Let's see. And we do really well. Wow. We beat 92% for runtime and 33% for memory. Oh, wow. That is way better than I thought it was going to be, especially because there's a lot of code in here. Now, I bet if we went through and cut this down, like eliminate some of these empty spaces, change some of these variable names, make them a little bit smaller, we could make this a little bit more compact and probably pick up a couple little percentage points here. But honestly, 92 is really good, and this seems fairly clear, so I wouldn't bother doing that. All right, so quick recap. On this one, we are given a list of pairs that were generated from some original list of numbers, and these pairs were adjacent numbers. To recreate our original array or our original list, we had to go through and basically find all of the adjacent numbers. We build a dictionary where the key is a number and the value will be a set of the adjacent numbers. That way we can access our pairs very quickly. We can just use our key to find the adjacent values to the left and right of that key value. Now that we have our key value pairs all sorted, not sorted, but stored nicely in this dictionary, we can go through and find the endpoints just by finding which one of our keys only has one value in the adjacent values. Once we find an endpoint, it's pretty straightforward. Now we can just follow that endpoint, looking at its adjacent pairs, and just follow the trail all the way down to the other endpoint. All right. That is it for me. I hope you enjoyed this. I know this was a quick one, but I don't have a ton of time these days, so bear with me. You can watch it again if you have to, slow it down if you have to, but I hope you enjoyed it. Hope you had fun, hope you learned something, hope you can go out and write better code.